Thought I'd make a little preview of this Matsuura Centroid retrofit that I'm doing. I'm going to turn it on real quick, run a little program, home the machine, run a little program, and then I'll turn the machine back off so the fans aren't on, and we can talk a little easier. So let me turn on the machine right now. I'm going to turn it on through the breaker box right now. I got a lot of temporary things done. I've already had this is the AC. I don't have I have the 120 hooked up, but I don't have the 220 hooked up to that switch. You might have seen this. I have lots of tool holders. It's nice. I'm working on the tool changer. It all works. I just have to get it jiving with the PLC, and so it all comes up automatically. In a second, it'll start loading up the software and communicating with the control. There it goes, and we'll home the machine, and then we'll run the program. Oh, I'll show you that. It's a little pendant. I guess you call it a pendant. I don't know. Control pendant. Hit start. Now you can see the Z is, the Z is already done. It's working on the X. There goes the X. Servo motor, ball screw, and connector here. Oiler comes through, drips on the gears. This servo actually burned up. Where do I have it? I don't see it. Laying around here somewhere. But the one that was on there burned up. But luckily I had a spare. Okay, so that's going to go, and then the fourth axis, it didn't have to go very far. It was already on home. So it just moved off and then zeroed out. So there is the DRO all set up, 4 axes, and I've already got a program loaded up in there, and just a little sample thing. It's going to cut up a little pocket mill in the air just to show. It's going to run at 500 RPM, pretty slow, but I'll speed it up with the RPM by manually and see if I can just get just to show the spindle turning up. Anyway. Here's the program that's already in there. The part location is already stored because it remembers. So you hit the start. So now it's running. That's the G code. That was one line of code, basically. I'll show you in a second. It's called conversational milling. So with just regular, it can do 3D, but with 2.5D it's really simple. 3D you have to kind of like make an arc and step it over and stuff like that, but you can pretty well do anything with it. Of course, offline program is a lot easier, I think, on 3D. On 2D, it's debatable. Depends on the job, I suppose. So anyway, I'll turn on the I'll turn this to manual, and it was set at 300, so it slowed down the spindle. It's actually running slower now. I'll turn it up by using the up and down arrows. It makes some noise that I don't particularly like. That's 3,000 RPMs, 3150. I don't think I had the, whoop, I guess it's done. The reason it's still running is because I'm in manual mode. Let me turn it down. That's 660. We turn it back to auto, and auto had already told it to give an M5, or I think it might be an M5 that stops the spindle. Well, what did it give? M30. That'll stop it. So what I was telling you about the software, the conversational. If you went to Cam, you went to your file. If you hit file, you go to your. You can pull up a file. You can load something that you've already done. But what comes up normally is just that's the circle mill. So there's just a few lines. Like the first line just is a description. Second line is calling a tool. You can call a tool change or just tell it the offsets, the Z offsets, the diameter, stuff like that. And that's what's really nice about this machine. You can actually have an offset that you can, if you cut it, measure it, and it's still a little oversized, or still have stock on it, you can play with the diameter offset, and you don't have to reprogram anything. Just change the diameter to something smaller diameter, and it'll cut a little more off. So anyway, if I go down to the circle mill, hit enter, you can see this is why they call it conversational. You tell stuff like the location of your circle, different things about the height, the diameter of the circle, what cutter you're using. Oh no, it's over here. I did that in the prior block. But you can see you can set feed rate, step over, how much you're going to step over, how much if you want to finish pass or not, how much you're going to take in that finish pass, whether you're climbing conventionally. You just fill out the information and it'll do the rest. So that's pretty much it for a sample of that. Let me shut it down. Before I shut it down, let's show you what this side looks like so you can hear the fans. I have a furnace filter on the front door here. Let me get the screwdriver. And there's my spaghetti factory. Oh, all right. So I've built a sub panel here. I don't have the fans on right now because I'm just doing something short. But here's the 3 fans in the top. You hear them revving up. They're pretty noisy, but you can feel a breeze. All right, so I'm gonna turn that back off and shut down so it's a little bit quieter, and then I'll explain what's going on in there. Let me turn this off. Or before I turn it off, let's jog the axes a little bit. Okay, so you come up here, you come off of incremental, go to continuous, go to rabbit speed, and we'll just leave it at 100%. So bringing the Z down, it's a little noisy. It's a little noisy, not too bad. I mean, the Y sounds the best. And then if the 4th axis, if you hit that, you see. So got all that going on, and right now I have this auxiliary button 3 hooked to the air draw bar. Of course, you have to have airline plugged in to get that to work, and I don't right now, so it wouldn't work at the moment unless I plug the airline. So I'll shut it down now that we've jogged things around a little bit. Wait a minute, let me show you. I hit shut down and power off. Touchscreen, all that. So we'll wait for it to power down the monitor, computer. Computer is built into that monitor, by the way. All right, let's just turn everything off. All right, let's look inside of here first. Well, look in the back. I've got the back closed off. That door used to be wide open, so I was trying to button the machine up so that I can get filtered air drawing through. Right now I have some tape on here. I have a filter in that box there, homemade filter. See it a little bit better here. Just some filter material that I draped over it. And that's the box that goes over to the other side. And the fan that pulls air out of the box out. And there's the VFD for the spindle. Like I said, it's not completely properly tuned yet. It's 10 horse, I believe. The spindle is 5 horse. This is the capacitor and brake for the carousel motor. Carousel motor is a AC reversible, so it needs that to work. The carousel has a I don't know if we're going to be able to see that. Probably not, but there's a rotary switch in there, magnetic switch or magnetic something, that as this carousel turns, it does like a spin, and it's kind of like a magneto sort of effect. It pulses about 5 volts down the line, and I have to take that 5 volts, convert it to something usable, send it to my PLC, and have the control count those pulses so that it knows where it's at. The home switch is simple. It's just a location. So it can home itself, but once you get going, it has to know where it is by counting how many times it pulses. And I've ran the motors, I've ran all the components, they all work. I just have to have the control tell it what to do, when to do, and watch out for this switch and that switch, all that kind of stuff. So I don't know if you noticed, but the spindle did stop pretty quick. I have 2 braking resistors. It's actually just one. I mean, they're in series. To get the proper ohms, I had to buy 2, but looks like plenty of resistor. I have, like I said, that's for the spindle. I have the AC coming in and then branching down here, so I have 220 right down here. It's feeding the fan. It's feeding these VFDs. And I have a power line going in parallel to each one. That's my coolant pump. That's my oiler. This was for the carousel up there when I thought it was a 3-phase. It's not a 3-phase. So I have an extra one here, which I may use for a second coolant pump over on this side of the machine, possibly. But as you can see, it's a pretty big mess. I've got extra wires that I don't have allocated yet. I didn't know how many connections I'd have, so I just put a big strip on there, and once I know exactly what's going to hook up where, then I will reduce that and properly do that. I have to find a good home for the braking resistors. Probably over here, maybe over here. I don't know, but it's just one of those things I got to figure out still. Like I said, the tool chain system I don't have figured out. I don't have my wire routing done. I cut a couple of things on here. This is just some, what is that called? Kind of plastic, PVC plastic. So anyway, I made a cover out of some, what was it called? Lexan. It's up there on the top of the spindle. It was a converter or adapter for a smaller fan. The big fan that was in there was all gunked up. I tried to save it, but the more I cleaned it, the more it fell apart. And then I couldn't find a good replacement easily, so I just thought, there's so many of those 4-inch fans, I'm just going to convert it for now and see what happens. I don't have it programmed yet to run when the spindle runs. Well, there are a couple, you can barely see, right past the red there, there's a hole. And that is a 10 millimeter by 1.5 millimeter thread, which I bought a couple bolts for. And there's one on each side. So I'll probably use this side over here and put a temperature probe in there, and that way I can use that to say when it gets this hot, turn on the fan. When it cools down to this low, turn it off. So that's another future project. Of course, there's covers all over the place that aren't on. This here, I made a little video, previous video on this a little bit, but this is the box that goes around it. This cover's laying around here somewhere, but this here mounts in up here. This here is for the connectors to go through. All that has to be hooked up. This has to be wired correctly, come out, go. I'm going to use the same connectors that are in there probably, and just rewire the pins with what I'm doing. And since I still have the other connector that will screw on, and I have the cable, then I will use that to run to my control. I'm thinking anyway. I don't know for sure. But anyway, this is all that stuff. It's in the works. It works, but it's in the middle. There's my coolant tank, my coolant pump. It's wired up. It works. It works by program. It's all good. The VFD's set up. Everything seems to be fine. Then this, like I said, the fans pull through here, and I guess they take the heat off of this heat sink here on the other side and draw it off. So I'm not sure if it draws any air from this from in here or just off of this heat sink. I'm not 100% sure how that works. I'll have to look at that closer. But I was kind of assuming that it pulled air from this cabinet. But if it doesn't, that's fine. What I'm thinking about doing is I have this plate that I pulled out of here. Goes on there, of course. And so I'm going to make... this is what I made. Another thing I made, I cut these 3 holes out. That connector, that line already had a connector set up. Those lines, I bought them. They already had these ends wired up. To simplify things, I bought them that way. And so since one end of this wire goes to that, like to the pendant or something like that, or that other control box, so you're not going to get that through the hole. These connectors are not, if you're trying to run a regular connector, it needs to run just through a line like this, not around the plastic. So I made these to basically, they're split and they just sandwich, and then the other half has a little clip that keeps them. So I'm going to do sort of the same thing for a temporary. I'm not 100% sure about the permanent solution on this plate. I'll put the fan up one side or the other, I don't know. But all these wires coming through, I have to basically cut a hole for them, make something to just block most of the air, so that I can pull air out of this cabinet through this channel here, and then into that. And I bought some plexiglass yesterday. I'm trying not to scratch it. So that goes up there, and I'm thinking I'll mount it up in there. It's got these little holes. Once I cut it to size, I might even cut like a little shoulder on so that the plastic comes out a little bit. It depends on how much thickness I need, and I got to seal it and everything. So whatever's needed there. But at the top, I was thinking about putting a hole here and a hole over there, and that will, when I'm pushing air down that tube, it'll go up, and then it'll have to come out one way or the other, and it'll pull that air from the monitor, and yes, also some air from that cabinet. So that'll be a project. Once I get that, I kind of have things buttoned off at least. You know, I've got this filter system there, and this is all closed off. The other side's closed off. The only thing that's not closed off right now is this box here. So that's kind of the next priority, really. So I'll tell you a little bit about this. I've got the power lines coming in, which they all need to be routed better and away from the control lines and everything. But I made this little sub panel. The bottom two switches are for my servos. The have a 16. Let's see. Oh no, that's a 10. That's a 10 amp. This is a 16 amp. The 16 amp is for the XYZ. So, you know, if you did that, it wouldn't work. Or, you know, anyway. So they supply, that one supplies power for these 3 transformers. I've got them hooked in parallel, going out to this capacitor, rectifier, and it goes into this contactor. And the 4th axis, same thing. It's the second relay, the 10 amp. It goes into this. See, it's a different voltage. The 4th axis works on that servo is a different voltage. So I had to set up 2 separate ones. Anyway, so the output of that goes in there, and it just this contactor came off of the Matsuura previously, and I'm reusing it. So I've got the 2 on that side, 2 on this side. The way it is actuated or canceled is this here is my e-stop contactor. When there's a fault, it will open, basically. For the most part, it will open. And there's a right here. There's I think it's these wires I've got hooked up. This line right here is just or maybe not. No. I've got this black one back here, little bit bigger wire, carrying 120 down to this one, 120 volts AC. That actually actuates that. So if I get a fault, that will open, cuts off my 120 power supply down to this coil. This shuts off, and then it stops power to my control. So that's how that works. That's not strictly by the book, but I'm thinking it will work. And that's where it comes in up there. That's the power up there. And these are the servo lines going out. That's X, Y, and Z. They're built into the box. Now, my 4th axis, that only holds 3 axes, you know, X, Y, and Z. I had to get a 4th axis. So this is my drive for the 4th axis. And this was my drive, that box there. I've stripped most of the stuff out of it, but you can see that it was pretty massive. This was, you know, back in early 1980s. So that's pretty much all I need to tell you about that. And of course, these are the encoders come in. This is the PLC, and it's mostly set up or needed for the automatic tool changer. So that will, I'm still figuring that out. I've got some of it hooked up, and some of it I have to program, and I'm still working my way through that mess. So until I get through it, I won't know exactly what wire goes where and whatever, so I'll probably have this mess for a little bit longer. I did get, you can see this power supply here that's pretty well used. It's being used for this control, which is what it's pretty well designed for, but I think it's also, if I remember right, it's also supplying power for this one, the fourth axis possibly. I think the PLC is being powered by that one. In any case, I'm using the 24 volts off of this one, which is, you know, driving the 5 and 12 volts for all this other stuff already. So this was what I was using for the 24 volts for the limit switches. Well, that's another thing I'll tell you about. Anyway, I decided to get a dedicated 24 volts because I don't want to, you know, strain this power supply any further. So there will be another 24 volt power supply just for, you know, stuff like limit switches. Which reminds me that I have, you know, X minus, X plus, Y minus, Y plus, Z minus, Z plus limit switches. Well, the I don't know if I can get under here or not. Maybe it might be dark, but you can see these are the limit switches, the gray box there, and the actuators are these things. It's one on each side. Well, there's actually more switches than you need. You only need one at each end, right? Well, I have 2 at one end and 3 at the other, like for example in my X. And I decided to use the 2 further out wires, the wires that are past the limit, as an additional e-stop. And I've done that on all my axes, my X and the Y, and I've got them hooked in here in series with each other. And it also, not only in series with each other, I don't know if I can find the right wires here, probably not, it's all a mess, but they go, I broke into the e-stop circuit, not here, I broke in up here, I believe, seems to me, one of these, I broke in somewhere, no, I did break in down here. Anyway, I broke into the e-stop to wire the extra limit switches. So if it gets past my normal limit switches, for some crazy reason, I can't imagine why, but if it does, I have an e-stop at a limit switch that's just beyond the regular limit switch, if all that makes sense. So I thought that was kind of interesting. I got that on the X and the Y, and the Z didn't have it. The Z didn't have it on the Z minus direction, or Z plus, I'm sorry. Z minus had an extra switch, but Z plus, there was only one there, and it lined up perfectly with the tool changer, so I can't really do a lot with that. But there was actually a switch there that wasn't being used. So if I alter the actuators and stuff, I should be able to, in the future, make a switch just beyond the limit switch that if it managed to get past, it would hit the e-stop. That's another project though. So yeah, I think that's it. Along with, oh yeah, this is my reference. It is mostly what I did, but it's not 100%. I had to alter several things. Not several, a few things. Like here's my PLC. That's my 4th axis. This is my main box. This is my terminal strip. What I got here? All these power supplies. This is T1 that's taking the. This is just. I'm not doing it this way, so I'm not using that. I don't think I haven't done this. These. I'm using that one. This is a generic VFD wiring. My VFD doesn't seem to have all these connections, so I'm having to scramble to figure out a few things about how to make my VFD work the way they've got things going here. But yeah, it's a head scratcher, and that's about it. Thanks.